Hey all, very good afternoon all my dear students. Just to let me know in the chat section, am I properly audible and visible to all of you? So, welcome to all of you this awesome P block chemistry session. Today it's going to be very amazing session, but before I start the session, everyone just to let me know, can you hear me, can you see me? Am I perfectly audible and visible to all of you? Today really we are going to start with the memory map, but yes, just I want to see the energy in the session if I am perfectly audible and visible to all of you. Just do let me know in the chat section, can you hear me, can you see me? I want to see my dear students, can you hear me, can you see me? Before starting anything, just do let me know in the chat section, can you hear me, can you see me? I want to see the Josh. I want to see the Josh in the chat section. That is going to reflect over there that I'm properly audible and visible to all of you. Yes, I'm waiting for your response. I got it. So, hit the like buttons, my dear students. It's your channel, Unacademy English, NEET English. This is your channel only. So hit the like buttons. I want to see the likes increasing or not. And if you're new, then do subscribe the channel. I want to see the increasing of likes to get increased. I want to see that. Today I'm going to give you brilliant memory maps, mind maps, and definitely that is going to increase your marks. That is going to give you the best rank in your examination. So everyone, just show me your love, affection, your energy in the chat section that you are ready. If you are ready to this awesome chemistry session, the P block, I am going to start with memory map, because in the P block, students find it very difficult to just to remember the oxo acids, and to remember the oxo acids in your brain, just to get the photographic memory map, that photographic plate, or better to say that image that should not get deleted. No need of further revision is required. Just to let me know in the chat section that we are ready. Yes, how is the Josh? Say everyone, I want to see in the chat section how is the Josh. Then only I will give you the memory map. That memory map is going to be in your hippocampus. And the hippocampus, you understand, if you know bio, anything which is going to the hippocampus, that is for always. And these two mind maps, they are really very important. They hold a lot of weightage. What I'm going to start with, two memory maps, they are really going to hold a lot of weightage for examination. So, oxo acids of phosphorus and sulfur. I will start with the memory map. I will start with the mind-blowing memory chart. Just let me know in the chat section that you are ready. If you are ready, then say yes, ready. Oh yes, I will tell you all the groups. I will tell you all the groups of inorganic chemistry, starting from that thing which is very important. And you know that just like in organic chemistry, aldehyde ketone chapter is very lengthy and very mark scoring. So the same over here, if I talk about P block, whether it is of class 11th or it is of class 12th, so I can see the energy, whether it is of class 11th or it is of class 12th. The most important thing is nitrogen and phosphorus, the nicogen family, that is the 15th group, that is very lengthy and very mark scoring. So we are going to start with P block of, see over here, P block. This is a brief intro. Myself, your HSP sir, you can call me Harendra or HSP, and this is your channel only. So once again I am telling you, if you are new, do subscribe the channel and hit the like buttons because this is your channel. Unacademy NEET English, this is your channel only, so I want to see the likes. So this is brief intro. I'm myself Harendra Singh Parihar, chemistry guru, magical chemistry guru. I did MTech in 2004, MSc 1999. After doing MSc, I cleared GATE, then JRF, and then MTech in 2004. I have passed my MTech, right? So I have been teaching from 20 plus years, produced number of ranks. If you talk about 2018, Mehak Arora, AIR AIMS 3rd rank. Then after that, Chaitanya Mittal, year 2019, 4th rank. At that time, AIMS was taking separate examination. Then in 2021, Suez Arora, brother of Mehak Arora. Then 2022, you know, the 1st rank, Tanishka Yadav, 715 marks, right? So let's start. P block. As you can see in the P block, we are going to start with class 12th chemistry of P block, inorganic chemistry of class 12th, and in the inorganic chemistry of class 12th, this group known as Nicogen. What? Nicogen. What's the name? P is silent over here, Nicogen. Most of the students, they are not able to remember what Nicogen and chalcogen. So, dear students, you can remember here is phosphorus. Phosphorus is silent and Nicogen. So, what I am saying, I will start from memory map. I am going to start with memory map because these memory maps are really very important for giving you the best marks and to have memory map, right? Now, let me start with oxo acids of phosphorus. Just remember one thing, when to use ik and when to use us. Are you ready? Are you ready? When to use ik and when to use us. When phosphorus oxidation state is +5 or +4. Do remember it. If the phosphorus oxidation state is +5 or +4, we will use ik acid. And lower oxidation state, suppose if I say +1, +2, +3, we will use us acid. I hope this point is very much clear to all of you. I will tell you each and everything, what's the ionization energy, what's the order of melting point, boiling point, each and everything. But first, I am going to start with memory map. Two memory map, that is oxo acid of phosphorus and oxo acid of sulfur, I am going to start with, and then I will give you each and everything. I hope this point is clear to each and everything, each and everyone. Just like Fe2 plus, we are going to use word us, and Fe3 plus, we are going to use word ik. Us, ik. Lower oxidation state means us. Higher oxidation state means ik. So this point is clear or not? Just to let me know. I will cover each and every point. I will let you know each and every point. Whatever the point students find out difficulties, that I will let you know. But just to let me know, is this thing clear to all of you? Whenever you are having oxidation state of +5, we will say ik acid. Whenever we are having lower oxidation state, we will say us. So higher oxidation state ik, lower oxidation state us. So let me start. See to it everyone. H3PO4. Just find out what is the oxidation state of phosphorus. I will say the oxidation state of phosphorus is +5 at this place, +5. Either you can find out like this, 3 into 1 plus phosphorus is being X and +4 into -2, that is coming out 0. So I will say x 3 and 4 2s are 8. That is plus 3 minus 8, 0. So x is coming out plus 5. You can do it like this, or you can draw the structure. Its structure will be like this: P double bond O, OH, OH, OH. This is phosphoric acid. Either you can call it phosphoric acid or you can call it orthophosphoric acid. But dear students, this structure you have seen number of times, multiple times. We all knew this structure very well from our childhood. When you were in class 10th, each and everything we are having in our brain. So do remember one thing very clearly: what is the necessary condition for a compound to be oxo acid? Phosphorus 5 valency. I am talking about 5 valency. This is the 5 valency I am talking about. This is the most compulsory part. What is the most compulsory part for a compound to be called as oxy acid or oxo acid of phosphorus? P double bond O, OH. Whenever we are having this much part, the basic part, the compulsory part, then only we are going to say it is oxo acid. If we are not having P double bond O, OH, we are not going to say it is an oxo acid. Is it clear? See to it why this part is necessary. If I say P double bond O, OH, you can see this hydrogen is acidic hydrogen. It can go like proton, will go like proton. When oxygen is going to leave this proton, you will get compound like this. And you can see very clearly. Can you apply your brain? Can you please let me know, can you apply your brain? Why I am going to say this hydrogen can leave like proton? This is loosely bonded proton. Why I am telling like this? Loosely bonded. This is loosely bonded. Loosely bonded H. Because once if it is leaving, it will leave and it will donate electron. If it is donating electron, there is negative charge, and this negative charge will do resonance. It will come over here, and these electrons, out of these, one electron will come to this place. This is an acid. This is an acid because its conjugate base is resonance stabilized. Are you getting my point? This conjugate base is resonance stabilized. This conjugate base is stabilized by resonance. From now, I will use SBR. SBR full form is, what is the full form of SBR? Just do write in the comment section. Just do write in the chat section what is the full form of SBR, because again I am not going to use this lengthy statement. What is the full form of SBR? I want to see in the chat section. SBR means what? SBR means what? Stabilized by resonance. SBR stands for stabilized by resonance. One student is asking, a number of students actually they are asking, yeah, very good, you are active. Each and every point of this session is really very important. So make a note of each and every point. Sit with pen and paper and try to make each and everything in your brain. I'm going to tell you little things. Then I will tell you the memory map. Right now I have not started to giving you memory map. I'm just telling you how to find out each and everything. Right? See to it. How to find out oxidation state. Number of students are asking how to find out oxidation state. You can do it like this also. See to it. Everyone. Who is more electronegative? Phosphorus is more electronegative. Hydrogen is less electronegative. Oxygen is even most electronegative. So what we can see, we will see two bonds, 1 and 2. So minus 2, it has taken 2 electrons, so it has lost 2 electrons. It has taken 1 electron, so it has taken 1 electron from here, minus I, it has lost 1 electron. This oxygen has taken 1 electron, so it has lost 1 electron. This oxygen once again has taken 1 electron, so it has lost 1 electron. Can you do the sum? Can you do the sum of all these numbers at this place? Kids, just do let me know. Can you do the sum on phosphorus? One way you can find out oxidation state of phosphorus is +5, or second way you can find out, I have already told you, H3PO4. Yes, I can see everyone is able to see it because this phosphorus has lost, if they are going to leave this phosphorus, it has lost 5. So the oxidation state is 5. Okay, anyone, whatever the doubts you are having, you can ask. You are free to ask. Now see everyone. See to it. I am going to write P double bond O, OH, OH, OH. Could you please help me? How many replaceable H plus ions are there? Could you please help me? How many replaceable H plus ions are there? That is the basicity. What is the basicity over here? Could you please help me? What is the basicity over here? I want to see in the chat section what is the basicity. Basicity means number of replaceable H plus ions. Number of replaceable H plus ions, or we can say that is the N factor of this acid. What's the value? What's that value? I want to see in the chat section. 3. Very good. Fantastic. Fantastic. So these 3 H plus ions are replaceable. And the name of this acid is orthophosphoric acid. Now kids, if I heat this compound, at 610 degrees Celsius, no need to remember this temperature, only heating must be given over there. We have to remove water. Water will get eliminated out. See to it. Water will get eliminated out. This will get positive charge and this will get negative charge. Can you see? Are you getting my point? This oxygen has taken 1 electron of phosphorus, it got delta positive, partial positive, and this proton has eliminated out. So we will get the bond over here. What type of bond? See to it. P double bond O, OH, coordinate bond O. We can write it HPO3. Just do let me know, should I call it ick or should I call it us? I want to ask everyone, I am asking one question. You have to answer it. Whether I have to write down us or ick, it all depends only on the oxidation state. If the oxidation state is higher, ick, lower, us. Ah, very good, very good. Your answer is absolutely correct. Oh, some of you are writing us. Oh, what is this? What is this? Maximum of you are writing us. You don't know how to find out. Oh my God, no. Oof. What are you doing? See to it. See to it. There are two ways. Either you can find out oxidation state like this, HPO3, 1 plus X plus 3, charge on oxygen is -2, and the whole compound is being neutral, so this is 0. This is 0. Just to let me know, how will you calculate it? What is the value of X? 1 plus X minus 6 is equal to 0. So X is equal to plus 5. This is one way. This is one way of doing this question. Another way you can do it over here, -2 plus 2, -1 plus 1. This coordinate bond is from more electropositive element, towards electronegative element. Whenever the coordinate bond, my dear kids, students, do let me know. This point you should have very clear in your brain. Whenever the coordinate bond is from more electropositive towards more electronegative, we will do the contribution of +2 the positive one and -2 towards more electronegative one. So this will experience +2 and this will experience -2. So how much oxidation state? Do let me know in the comment section what is the oxidation state of phosphorus in this. That is coming out +5. So remember that whenever water is removed from one molecule, you will say meta. You have to use word meta. Which word you have to use? Meta. When one mole of water has been eliminated out from the orthophosphoric acid, we will use word meta. These ortho, meta, para are not for benzene. In benzene we were using ortho, meta, para like that. These are not those words. In inorganic chemistry, meta means if from ortho one mole of water, one molecule of water is removed from one molecule of orthophosphoric acid, we have to use word meta. So this is metaphosphoric acid. So let me write down, this is metaphosphoric acid. Now this metaphosphoric acid is unstable. So it will trimerize. It can polymerize. So let me write down its trimeric form. It's given in the NCERT, the trimeric form. So let me write down its trimeric form. HPO3 whole thrice, trimer of metaphosphoric acid. Metaphosphoric acid. Let me write down. See to it. How to draw it? It is given in NCERT. Let me tell you the page number. Page number 179. 179 NCERT. Class 12th. First part. It is given in NCERT on page number 179. You can see an NCERT also, right? Now see to it. How to draw it? P double bond O. Oh, let me tell you how to keep in your brain. POP. How many P? Oh, 4 P I have drawn. We have only 3 P's. O and P. Can you see? Double bond O, OH, double bond O, OH, double bond O, OH. So this is the trimeric form of metaphosphoric acid. Now, one more thing you have to keep in your brain. One more thing, the most important thing. But before I am writing, let me clear it. Let me draw it once again. So just do let me know what I have written over here. What I have told you over here, POH, OH, OH. I have removed one water from here. I removed one water from here by heating it at 610 degrees Celsius. What I got? I got HPO3. This was orthophosphoric acid. And this is your metaphosphoric acid. And what I said, this metaphosphoric acid trimerizes to give you HPO3 whole thrice. This is the trimer form metaphosphoric acid. But now the most important point is, if I take 2 moles, if I take 2 moles of this orthophosphoric acid, just keep in your brain what I am talking to you. If I take 2 moles of this orthophosphoric acid and I am going to remove water, higher temperature will be required or low temperature? Just think in your brain. If I am going to take 2 moles of this orthophosphoric acid, see to it. If I am taking 2 moles, P double bond O, OH, 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 one more mole, P double bond O, OH, 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 and now I am removing 1 mole of water. Can you see? Its O is gone, positive charge, its proton is gone, negative charge. What I am going to get? Dear kids, just let me know what I am going to get. And what should be the name? What should be the name? P double bond O, OH, OH. This bond O is there. See to it. Everyone see to it. O. And from this side also. Oh, this is one O. Let me clear it. O. P double bond O. OH. OH. Can you guess what's the name of this compound? And temperature required is less, 110 degrees Celsius only. No need to remember the value of temperature. Just keep in your brain that less temperature is required. There was high temperature was required, and there low temperature is required. Lower temperature is required. And what do you call it, my dear students? Water is removed while taking 2 moles. Just to remember. Yeah, very good. That's really awesome. That, yes, your answer is absolutely correct. We will call it pyro. See, what's the oxidation state? How to find out the oxidation state? -2 plus 2, -1 plus 1, -1 plus 1, -1 plus 1. What's the oxidation state? 2, 3, 4, 5. 5. For 5, what are you going to use? Us or ik? Do let me know in the comment section, that chat section, ik or us? Hey everyone, us or ik? Ik. And remember that this is meta, this is ortho, and this is going to be pyro. Remember that whenever you are taking 2 molecules, and from 2 molecules, by combination of 2 molecules, that is going to give water, we will use word pyro. Pyro means heat. You are going to say pyrophosphoric acid. Pyro. Your examiner will definitely ask pyrophosphoric acid. What is the basicity in pyrophosphoric acid? I can call it H4 P2O7 pyrophosphoric acid. What is the N factor? What is the basicity? So basicity is 4. If examiner is asking how many POP linkages are there, just do let me know. Chat section, my dear kids, every guys, just write down in the comments at that chat section each and everything. How many number of POP linkages are there? How many POP linkages are there? There is one POP linkage. This is your answer. So I hope this point is very much clear to all of you. What is ortho? What is meta? What is para? If this much is clear, ortho, meta, para, I have told you each and everything what is ortho, meta, para. If it is clear to all of you, show me your Josh. Thank you, Aman Jhaji, thank you. Just show me your Josh. If each and everything is clear to all of you, if you are able to understand, show me the thumbs up. If each and everything is clear to you. So what I was writing, what I was telling you, just revise it. I have written H3PO4. I am writing over here. You write down what I am writing. You write down the names. If everything is clear to your brain, if there is photographic memory in your this brain, just do write down the names in the chat section. What's the name? What's the name? What's the name? I want to see. I'm asking what's the name of this? What's the name of this? Orthophosphoric acid. Okay, I'm writing here H4P2O7. How many moles I have taken? How many moles I have taken? I have taken 2 moles and I remove water from it. 110 degrees Celsius. What I have got? What's the name of this compound? Let me know in the chat section what is the name. Name is pyrophosphoric acid. If I remove one water directly, what's the name of the compound? What is the name of the compound? HPO3. Or I can write HPO3 whole thrice. Metaphosphoric acid. Metaphosphoric acid. Till now, these 3 points are very much clear to all of you. This much is very clear to all of you. Now, if I remove one oxygen from here, if I remove one oxygen from this, something I am removing, something is less, I am removing one oxygen. If one oxygen is less, if something is less, will you call it hyper or hypo? If something is less, will you call it hyper or hypo? H4P2O6. How I am going to make it? P double bond O, OH, OH, P double bond O, OH, OH. How much is the basicity? How much is the basicity of this compound? Basicity is still 4. What is the name of this compound? I will call it ick or us. Ick or us depends. Yes, hypo. You're right. Absolutely correct. Hypo. But along with hypo, what should I use? Us or ick? Us or ick? That depends on the oxidation state. What is the oxidation state? See to it. -2, -2, +2, -1, +1, -1, +1. How much? 2, 3, 4. 4. Either you can do it like this or you can do it like this. See to it. H4P2O6. How to do it? 4 into 1 plus 2x plus 6 into -2 is equal to 0. So 4 plus 2x minus 12 is equal to 0. So 2x minus 12, 4 minus 8, 2x minus 8 is equal to 0. So 2x is equal to 8 and x is equal to 4. Either way you can do it, you can find out the oxidation state, but just do let me know. Hypophosphoric acid. Yes, Adina ji, you got the answer. Everyone, you just think like this. Yes, everyone. If you are getting any benefit, just do let me know in the chat section that yes, each and everything is very much clear. So its name is going to be hypophosphoric acid. If till now each and everything is clear, where to use word ortho, where to use word meta, where to use word pyro, and where to use word hypo, where to use the word ick, or where to use the word us. Us is still not, yeah, I will let you know where to use word us. It is yet to come. Thank you, Rame Ramji, thank you. But my dear students, everyone, just do let me know, because I'm very new to this channel. I want to form a good bond with you. So this is the only medium that I can understand that my students, they are getting any benefit or not. It's getting directly, it's whether it's forming a image. Inorganic chemistry means image formation. The game is all about image formation. If it is getting like a photographic plate in your memory, then only you are getting benefited. Otherwise, you are not getting marks. You are not going to get. This is very, very important. If it is getting, it is forming an image. Thank you, Cricket Guruji. It means a lot. Okay, Deopriya ji, thank you. Now see, wow, thank you Sandhya ji, very good comment. You are awesome, you are copying and pasting everything in my mind. Yeah, that was required. That was my aim, and my aim is coming true. My aim is getting, yeah, it's coming true. Now see, you have to help me. I'm writing the name, I'm writing the compound, you have to name it. Are you ready? Each and every question is going to be correct. You will get full marks in your examination if you are able to copy it in your brain. Just do let me know, are you doing each and everything along with me? Just do let me know. I'm going to write the structure and you have to name it. Just make a promise. Whatever I'm going to write, you will write the name of that compound in the chat section. Just promise. Make a promise. Whatever the structure I'm going to draw, you have to name it. You have to name it in the chat section. Yes. Let's see what's your speed. Let me check it out. What's your speed and what's your brain? Brain and speed I want to check. See. It's your channel only, so see to it. Everyone. So what is it? What do you call it? Once again I'm drawing it. I want to see the name. Again I am drawing it. Just do let me know what's the name. Yes, name it. Orthophosphoric acid. Yes, correct, absolutely correct. Now I'm not going to write the name. You are supposed to write down the name. What's the name? What's the name of this compound? Till that time, let me write down name of this compound. Orthophosphoric acid. If you want full marks in inorganic chemistry, you have to write down the name, then only you are going to get marks. Pyrophosphoric acid. Absolutely correct. I can see you are going on the right path. You are going on the right path. Yes, I can see. Now, P double bond O, OH, coordinate bond O. What's the name? 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 Anyone new on this channel, do subscribe the channel and hit the like buttons. Hit the like buttons also if you are getting any benefit. If you are benefited, if you are getting any benefit, do hit the like buttons. Phosphoric acid. Now see to it. Everyone see to it. P double bond O, OH, Papa, P double bond O, OH, what do you call it? H4, P2, O6. This was H4, P2, O7. This was H3, PO4. This was HPO3. What do you call it? What do you call it? What's the name? What's the name? What's the name? Yes, absolutely correct. Yeah. Oh, great. Like a bond, like a bond. Fantastic, fantastic. It is hypophosphoric acid. Hypophosphoric acid. Fantastic, really awesome, really awesome. Everyone is able to do it, everyone. I think in everyone's brain, one pic has been formed, one photographic memory has been formed. Now see to it, what I'm going to write. See, everyone. Now see everyone, if I'm having one oxygen less than this, one oxygen less than this, see to it. One oxygen less than this, I will get P double bond O, H, OH, OH. Can you see anything new? Can you see anything new in this compound? Once again I am drawing this structure. I am making this structure a little bit bold. See to it. I am going to draw this structure a little bit bold. P double bond O, H, focus over here. Is there anything new? See to it. Is there anything new? See to this. See this bond. See this bond. Anything new? Just do let me know in the chat section. Anything new? New. This bond is indicating that this compound is reducing agent. This bond is indicating that this compound is reducing agent. Can you understand? If hydrogen is directly attached, to the phosphorus, do remember what I am telling you. If a hydrogen is directly attached to the phosphorus, this is responsible for making it reducing agent. That means this compound can undergo oxidation. This compound can undergo oxidation. Now, kids, just do let me know what is the oxidation state, because I have to name it. Yeah, its basicity is 2. Very correct. Really awesome. Basicity is only 2. Otherwise, people used to say H3, PO3. What mistake they are doing? They see here H3, they say N factor is 3. When say this is compound, they say, oh, its N factor is 3, but N factor is not 3. Don't do that mistake. N factor is not 3. N factor is not 3. Here the N factor is Only 2. Only 2. What is the oxidation state? Do let me know in the chat section. What is the oxidation state over here? See to it. -2 +2 +1, this time +1, -1, -1 +1, -1 +1. How much? -1 +1 cancelled out. This cancelled out. +3. What do you call it? Us or ik? What do you call it? Us or ik? Just do let me know in the chat section. What do you call it? Us or ik? Us or ik? It's 3. It's 3. It's 3. Will you call it us or ik? Will you call it us or ik? You are going to call it us or ik. Just do let me know in the chat section. Yes, I'm waiting. I'm waiting. Us, absolutely correct, absolutely correct. So this is ortho phosphorus acid, phosphorus acid, orthophosphorus acid. It has got another nickname, that the trivial name, its another name is phosphonic acid. Remember that. Do remember it. What's the name? Phosphonic acid. What I'm saying? Phosphonic acid. Phosphonic acid. Can you get it? What's the another name? Another name is phosphonic acid. Phosphonic acid. This is ortho. This is ortho phosphoric acid and this is ortho phosphorus acid, because all they are same. One is ik, one is us. One is us, one is ik. More oxidation state means ik, less oxidation state means us. If this much is clear to, no, it's not phosphonic acid. Srejan Beraji, no, it's not phosphonic acid. It is phone, the phone. It's not phonic. It's a phone one. Phosphonic, phonic acid. Remember that it is phosphonic acid, not phosphonic acid. It's phosphonic acid. Okay, I think this much is clear to all of you. This much is very much clear to all of you. Now see to it. If I remove one oxygen from here, I will get, see what I am going to get. If I remove one oxygen from this, I will get H3PO2. H3PO2. See to it. P double bond O, H double bond O. This is known as, yes, something is less. Everyone was saying phosphonic acid. This is actually phosphonic acid. Remember it. Number of times questions has been asked. Number of times questions has been asked in NEET examination. Number of times. This is phosphonic acid. Phosphonic acid. Phosphonic acid, or you can call it hypophosphorus acid. Hypophosphorus acid. Hypophosphorus acid. Hypophosphorus acid. I think this much is clear to each and everyone. What is phosphonic? See only the difference of in phosphonic and phosphonic acid. Let me tell you what's the difference. See, H3PO2, H3PO3, see to it, phosphonic acid, and its name is phosphonic acid. What's the difference? Only a little bit difference is over there. See to it, here is I and there is O. Here is I, there is O. Number of times they have asked the question. And this is really very, very important when this compound reacts with benzene diazonium chloride. If you see NCERT part 2, class 12th, if you see NCERT part 2, class 12th, and the page number 396 in old NCERT, 396 in old NCERT, and 404 in new NCERT, you will see when this phosphonic acid reacts with benzene diammonium chloride, what answer you will get? You will get this plus benzene. So this is given in your page NCERT, and this is the most important question which has been asked in number of exams, number of times, whatever the type of exam. So it is totally a redox reaction, totally a redox reaction. It is totally a redox reaction, that this compound is undergoing oxidation. So this is your reducing agent. This is your reducing agent. And you know that whenever we are provided with reducing agents always undergoes oxidation. It always undergoes oxidation. So you can find out oxidation state is +1, and that has converted 3 to the 6 and 3 +3. +1 has got converted to +3, that this molecule is undergoing oxidation, and that benzene diammonium chloride has got reduction. Is it clear to all of you? One oxygen, this is I got changed to O, I to O. What's the difference in between phosphonic and phosphonic? I got converted to O. Is it clear to each and everyone? If this much is clear to all of you, my dear kids, hey guys, if this much is clear to all of you, hit the like buttons. And if you are new to this channel, subscribe it. And if this way helping you out, just show me in the chat section that you are getting benefited. Is in this way, if you are getting benefit, do let me know, my dear kids. If it is making sense, if you are getting benefit, just do let me know. Wow, Kanishta ji, thank you. It means a lot. It means a lot, really. Oh, great. I can see your love in the chat section. Oh, I'm thankful to you. I'm feeling, you can't understand how great I am feeling on this Unacademy NEET English channel because of your love and your this much of respect and this what's how much you are getting benefited. This is the thing. Now, see to it. If I write, NCERT used to write one thing. NCERT used to write one thing. I will let you know what NCERT used to write. P double bond O, H, OH, OH. NCERT says, if hydrogen is attached over here, then the compound will act as reducing agent. According to NCERT, what I am saying, according to NCERT, if hydrogen is attached directly with phosphorus, then that entity will act as reducing agent. Then that entity will act as reducing agent. My dear students, what do you want? Should we go with the line of NCERT, or should I tell you, should I let you know one fundu thing so that no need to remember NCERT line? What do you want? What do you want? Sandhya ji, I will come to that point. Yes, your point is very good, but let me come to that point. What do you want? You want to cram this line, or you want something brain apply? You want something, my trick. See, I will give you logic. I will give you my logic. See, my logic is phosphorus belongs to which group? Phosphorus belongs to which group? Phosphorus lies in 5th group. That means its atomic number is 15. I can write what? I can write neon, and I can write 3s2 3p3. Am I right? Am I right? This is the electronic configuration. This is the electronic configuration. Is this much clear to all of you? The logic I am telling you from the very basic. I will take the very basic and I will let you know. See, everyone, phosphorus is having 5 electrons in the outermost orbit. 5 electrons. Hey, this is a man. You can say this is a man, phosphorus man. This is a man, phosphorus man. I always consider elements like human beings. I always consider elements like human beings. We can see human beings. We can see human beings. But every human being is with money. Everyone is with money. Everyone has money, but we can't see money. We can apply our brain only. So electron I treat electron like money. Everyone has money, but we cannot see money. Those who can see money, they can apply their brain. Are you agreed or not with this fundamental thing? I will let you know the whole chemistry on the basis of these two things only. One, I take element like money, I treat element like money, and I treat electron like money. So I treat element like human beings, and I treat electron like money. Only two things. Only two things are required. One is human being, another thing is money. Suppose somebody has bought car. Everyone will say, oh, what a great Audi, red Audi. But the minded people will say, oh, he is having too much money, that's why he bought this car, so costly car he bought from that much of money. Others will say, fools will say, oh, what a car, what a car. But brilliant people will say, money is involved. So it is having 5 electrons in the outermost orbit. How many more electrons it wants? How many more electrons? Just do let me know. Phosphorus needs how many electrons to complete its octet? Phosphorus need how many electrons to complete its octet? Just do let me know in the comment section. It is in need of 3 electrons. So by accepting 3 electrons, it will become P3 negative. Its octet will get complete. And how many electrons it should lose to complete its octet? It can lose 5 electrons. It can lose 5 electrons. It can become P plus 5. So its range is how much? Its range is from plus 5 to minus 3. Its range is from, phosphorus range is from minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, plus 4, plus 5. Can you see? If phosphorus is in this oxidation state, phosphorus is very, very good reducing agent, means he is rich. This means phosphorus is rich, very, very rich. It can lose money, it can donate money, donor of electron. And if phosphorus is over here, phosphorus is good oxidizing agent. That means phosphorus is a beggar. He can't donate money. Phosphorus is a beggar. Phosphorus is beggar. It can't donate money. Are you agreed? Everyone agreed with my point? Phosphorus is a beggar. Now if phosphorus is in between, these oxidation state, that means what do you call it? Phosphorus is reducing as well as an oxidizing agent. Am I right? Do let me know in the chat section. Am I right or not? Even NCERT used to write. NCERT says, according to NCERT, phosphorus in between plus 5 and minus 3 will undergo disproportionation reaction. Agreed or not? If this point is very much clear to all of you, do let me know in the chat section that you are able to get it. I'm over here. Just everyone show me the thumbs up if this much is clear to all of you. I will teach you inorganic chemistry with the help of redox reaction, with the help of physical chemistry. I am not saying you have to cram it. No need to cram inorganic chemistry. You are going to kill it. You will get it. This is my promise. I am your HSP. Your HSP is going to let you know each and everything. Just you have to go along with me. You have to say yes or no. You are getting this point or not. It's not the part to cram. This is the part to know it with the help of physical chemistry. I will let you know. I promise. From the internal core of my heart, I promise I will let you know. Just do let me know if this is clear to all of you. Yes. Now, if this is clear, see. If this much is clear, see to it. What I said, we were having H3PO3 or we were having H3PO2. And NCERT was saying, according to NCERT said if hydrogen is directly attached, once the hydrogen is directly attached, they will act as what? They will act as reducing agent. Now see my logic. What is the oxidation state? Over here 3 to the 6 and 3 plus 3, 2 to the 4, 3 plus 1. See, just see to it. They are having electron or not? They are having electron. They are not in their maximum oxidation state. They are not in their maximum oxidation state. So they are reducing agent. And if you call it about H3PO4, H3PO4 is in plus 5. Can't donate electron. So it is oxidizing agent. Are you getting my point? Is it clear to all of you? Is it clear? Now see, just try to find out which are oxidizing and which are reducing agent. I am going to give you one question. Find out. NEET will ask you one question. Question is, find out number of oxidizing agents. So compounds are H3PO4, HPO3, H4, P2O7, H3, PO2, H3, PO3. Options are, first option is 5, second option is 3, third option is 1, fourth option is 2. Do let me know in the chat section what's your answer. I'm waiting for your answer. Everyone, what's your answer? This is absolutely new question. I'm going to give you new questions, then I will give you the quiz. I will teach you each and everything. Just do let me know in the chat section what's your answer. Do let me know in the chat section. Yes. 3. Everyone is saying 3. Do it properly. Do apply your brain. Just apply your brain. Apply your brain, kids. Don't give answer like this. Oh, you are saying third option. Okay, third option. Absolutely correct. This is the option. Oh, no. This is wrong answer. Oh, those who have given this to be the answer, this answer is going to be wrong. Just apply your brain. Everyone apply your brain. 5. Oh, what happened to you? Okay, just find it out. What's the oxidation state over here? +5. So this is not your, oh, this is your answer. 1, oxidizing agent. This HPO3 plus 5 oxidizing agent. This plus 5 oxidizing agent. This plus 2 to the 4 and 3 plus 1. No. This is 3 to the 6 and 3 plus 3. No. So what is the correct answer? This is the correct answer. Those who got the correct answer, just show thumbs up for themselves. Yes. And those who got wrong answer, thumbs down. Whether, let me see, thumbs up or thumbs down. Let me check it out. Those who got the correct answer, just show thumbs up and hit the like buttons. I want to see. Yes, if you are new, do subscribe the channel, and otherwise hit the like buttons. I want to see. Wow, great. Yes, only one student got the wrong answer. What I can see, only one student got the wrong answer. Meenu, Kuti, Gokul, Maran, everyone is getting the correct answer. Only I can see only 2 or 3 students, they are getting, wow, hearts. Oh, great. Nilofares, yes, very good. Now see, everyone, see to it. Just wait. Now, everyone, see to it. NCERT is writing, according to NCERT, together PP and pH bond is not possible. Together PP and pH bond is not possible. What does it mean? How it can be used in your examination? See to it. This will come like this. If I want to make hypophosphorus acid, see to it, everyone, see to it. If I am having compound like this, P double bond O, OH and H, what is this? This is ortho phosphorus acid, right? Now, if I take two molecules and remove water, from it, P double bond O, H, OH, P double bond O, OH, H, and suppose water has been eliminated out. Water has gone. You can see this is developing positive charge, and over here negative charge. What you are going to get? You will get P double bond O, H, OH, O, P double bond O, H, OH. What do you call it? Just do let me know in the chat section. What do you call it? If you got my point, pyrophosphoric acid. No. Rathega Chinmayaji, your answer is wrong. What I have told you, just follow what I have told you. The points which I have told you, if you are not able to follow it, you won't be able to get the correct answer. This is the mistake, and options will be given over there. If you are saying this is pyrophosphoric acid, your answer is absolutely wrong. It's not pyrophosphoric acid. If you are writing pyrophosphoric acid, examiner will give you big 0. If you are writing pyrophosphoric acid, examiner is going to give you big 0. He will write 0 out of 20 marks. He will put big 0. If I am being your school teacher, I will give big 0. Just try to find out. Somebody is writing hypo. No, dear students, what I have told you, if you are taking 2 molecules of it and removing water, you have to use word pyro. Pyro to you have used. Word pyro has to be used, but try to find out the oxidation state. What is the oxidation state over here? -2 plus 2 plus 1 minus 1 minus 1 plus 1 minus 1 plus 1. What is the oxidation state? Do let me know in the Chat section, -1 +1, how much? +3, +3. What word I have to use? For +3, what should I use? For +3, what should I use? Just do let me know in the chat section. What should I use? What I have taught you? Yes, us, pyrophosphorus acid. So the answer is pyrophosphorus acid, phosphorus acid. Have you become pro or not? Have you become pro or not? Have you become pro or not? Do let me know. Do let me know. Have you become pro or not? Now see, if I remove one oxygen, if I remove one oxygen from here, what do you call it? If I remove one oxygen from here, and if I am writing like this, P double bond O, H, OH, P double bond O, H, OH, what do you call it? Just do let me know in the chat section. What do you call it? What do you call it? If you are saying this is what? If your answer is hypophosphorus acid, just do let me know. Yes, your answer is hypophosphorus acid. How many of you got it? This is hypophosphorus acid. Just do let me know in the chat section. How many of you got it? This is hypophosphorus acid. Right on show. Aman Jha, yes. Yes, Aman Jha ji, you are absolutely correct. Absolutely correct. You are absolutely correct. This is not possible. This is not possible at all. This is not possible at all. This is not possible at all. Why? This phosphorus and hydrogen and this PP bond is not possible. These two things are not possible together. These two things are not possible. pH and PP. pH and PP altogether not possible. Not possible. Not possible. Not possible. Not possible. Have you got it? This compound does not exist. This compound doesn't exist. Everyone got it now? So oxy acids of phosphorus I have told you. Now see to it. I am going to give you the most important thing. See, everyone. Where phosphorus is stored. Phosphorus is always used to kept in water. Phosphorus is same inside the water, that is P4, white phosphorus is safe in water. But when phosphorus reacts with oxygen, two possibilities are there. When phosphorus reacts with oxygen, two possibilities are there. It catches fire. It catches fire. Now, it will form two types of oxides because phosphorus atomic number is 15. If I write neon 3s2 3p3, it can show 5 oxidation state or 3 oxidation state. If all 5 electrons are going, it will show +5 oxidation state. Only 3 electrons are gone, it can show +3 oxidation state. Two possibilities are there. So when phosphorus reacts with oxygen, it can form two types of oxides. That all depends. It all depends how much oxygen it has taken. So it can form P2O3 or P2O5. P2O3, P2O5. But why phosphorus reacts with oxygen? This is the main question. This is the main question arises, why phosphorus reacts with oxygen. See to it, everyone. Phosphorus, you can see lone pair, 1 lone pair and 3 sigma bonds plus 1 lone pair. How much it is coming? 4. So the steric number is 4. 4 means sp3 hybridized, and sp3 hybridized means angle is supposed to be, this is expected bond angle. Expected bond angle. Can you see what I am writing? Expected bond angle is 109. expected bond angle is 109, but you can see this cycle, this is having only 60 degree angle. Supposed was 109, actually it is only 60 degree. You can see the strain of 49 degree. 49 degree strain is there. That means P4 is highly strained. That's why it is highly poisonous also, highly poisonous, unstable. And just to get some relax in the bond angle, it reacts with oxygen. It reacts with oxygen just for getting relax in the angle strain. So, see what it is going to do. P4 when reacts with oxygen, it will form P2O3 and its dimer will be P2O3's dimer will be, see, twice of P2O3. If I write, we can write P4O6. Now check out how will you write P, 1P, 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 east, west, north, south, 4P, right? POP, it has become, PP has become pop, PP has become pop. Can you see PP has become pop? Once the PP has become pop, relax in the angle strain. It has got relax in the angle strain. Can you see? Still lone pair is there on phosphorus. So, examiner will ask you question, how many POP linkages are there? First question arises, how many POP linkages? How many POP linkages? Just find out the answer. Just find out the answer, how many POP linkages. So, the answer will come out 1, 2, 3, 4, 5, 6. Answer will be 6. Now, the question number 2, how many lone pairs? How many lone pairs? That was the question number 1. This is the question number 2. How many lone pairs in this compound? How many lone pairs? How many lone pairs? Just find out how many lone pairs. Let's see. Let's check it out. How many lone pairs? No, answer is not correct. How many lone pairs? How many lone pairs are there? Just waiting for answer. How many lone pairs? Everyone, just do let me know how many lone pairs. So, everyone's answer is going to be wrong. See everyone, one phosphorus is having one lone pair. One phosphorus is having one lone pair. How many phosphorus are there? 4 phosphorus. So, 4 phosphorus will give 4 lone pairs. One oxygen is having 2 lone pairs. Can you see? Is it clear? One oxygen is having how many lone pairs? 2 lone pairs. How many oxygens we have got? 6 oxygens we have got. How many oxygens? We have got 6 oxygens. So, 6 oxygen means 6 into 2, 12. So, 4 plus 12 lone pairs. Answer will come out 16 lone pairs. Have you got the answer? Everyone, have you got the answer? 16 lone pair. Those who got the correct answer, just show thumbs up. Those who got. Now, let me tell you another one. If it is forming a bond like this, P4O10, P4O10, how will you draw it? One phosphorus, another phosphorus, another phosphorus, another phosphorus. East, west, north, south. Oxygen, 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 oxygen. Now, oxygen and oxygen, and there was one lone pair. It will donate that lone pair also, P double bond O, P double bond O. Now, you can see what is the oxidation state of phosphorus. It's +5. It has donated all the electrons. Now, examiner is going to ask how many lone pairs. Now how many lone pairs? How many lone pairs? How many lone pairs? Just do let me know in the chat section. How many lone pairs? What's your answer? So now phosphorus is not having any lone pair, only oxygen they are having lone pair. Each oxygen is having 2 lone pairs. So 10 into 2, that will come out 20, only 20 lone pair, because right now phosphorus is without lone pair. Without lone pair. I hope this is clear to all of you. This is without lone pair. This point is very much clear to all of you. 20 lone pairs. Clear? If your answer is correct, if you got the correct answer, hit the like buttons. I want to. This is very bad. You have given so less likes. Those who got the correct answer, just show me thumbs up for you only, for you people only. Okay. Now let's start with oxy acid of sulfur. But before I go to the oxy acid of sulfur, let me tell you each and everything, that table I am going to tell you. See everyone, it starts from here. In the NCERT it starts from here. In the NCERT it starts from here. Now let me tell you each and everything. Wait, see to it. See everyone. Nitrogen, phosphorus, arsenic, antimony, bismuth, SMC. So the trick for it is, first you should learn it. This is first period, second period, third period, fourth period, fifth period, sixth period, seventh period. The mnemonic for it, first to let me know in the chat section. What about oxides? I will let you know. Nitrogen, phosphorus, arsenic, antimony, bismuth, MC. Nitrogen is okay, nitrogen is okay, no problem is there. But if you see phosphorus, this is also okay. Arsenic is also okay. What is this? Antimony. This is antimony. But antimony starts from money. Antimony. Actually it is stibbium. And this is radioactive. No need to go for it. This is radioactive element. Now how to learn it? Do you want to have trick for it? Do you want to get? Yes, I will let you know nitrogen oxides, each and everything I will let you know. Just let me know. Do you want a trick for it? See what's the trick? Trick is, and for NEET paper answers, NEET paper answers will be provided by SBI, will be provided by SBI with the radioactive mic, with the help of radioactive mic. I would like to say directly you can learn this. Otherwise, if you can't learn it, if you can't memorize it, nitrogen, phosphorus, arsenic, antimony, bismuth, then only you can use this trick. This trick I made for you people. NEET paper answers will be provided by SBI with the radioactive mic. How is the trick? If the trick is good, show me your energy in the chat section. If the trick, you like the trick, if you like the trick, just newspaper answers will be provided by SBI with the help of radioactive mic. Okay, that's really awesome. Now see everyone, what I have written. Nitrogen, you have to make a memory in your brain, then only you are going to get benefit. Nitrogen, phosphorus, arsenic, antimony, bismuth, MC. What I have written over here: first period, second period, third period, fourth period, fifth period, sixth period, seventh period. Now see how to find out the atomic number. They can ask you the atomic number. Its atomic number is 7. Then how to find out atomic number of rest of the other elements? How to find out atomic number of rest of the elements? You know the magic numbers. You know the magic numbers. Magic numbers are 2, 8, 8, 18, 18, 32. Magic number. These magic numbers, if you know these magic numbers, from where we have got these magic numbers? Question arises from where we have got these magic numbers. See, in the first period we have only S. In the first period we have only S subshell. Second period SP. Third period SP. Fourth period we have got SDP. Fifth period we have got SDP. Sixth period we have got SFDP, and seventh period also we have got SFDP. From the physical chemistry atomic structure, I hope this point is very much clear to all of you. Now see everyone, see to it everyone. S can hold maximum of 2 electrons, so 2, magic number 2, 2, 6, 8, 2, 6, 8, 2, 10, 6, how much? 10, 6, 16, 2, 18, 2, 10, 6, 18, 2, 14, 10, 6, 32, 2, 14, 10, 6, 32. So we have got the magic numbers. We have got these magic numbers. Now we can find out the atomic number. How to find out the atomic number? See to it everyone. How to find out atomic number? Add 7 plus 8. 7 plus 8 is how much? 15. We have to write down at the base 15. Now don't do the mistake. Don't add 2 times 8. Don't add 2 times 8. Why? See to it. If we talk about fourth period, we have got d orbitals also. D, that means we are supposed to add 18 to it. 15 plus 18, how much? 15 plus 18. Yes? 33. 33. Now 18. Once again we are supposed to add 18. How much? 18. Yes? 51. Once again. Now you are supposed to add 2 times. We have added 18. Now add down 32. Just add 30 to it. 51. 83 you will get, and 115 you will get. Am I right? Can you see to it? 32 once again. These are the atomic numbers. Are they visible to you? Are you visible? Is it visible to all of you? Can you see the atomic numbers? Everyone, is it clear? Are you able to see it? Now how to write down the electronic configuration? See to it. See to it. Helium. Helium means already 2. Already 2, and it is 7. It is already 2. So how much should I add? 5. So I will add 2s2 and 2p3. Now for this, neon. Neon, helium, neon, argon, krypton, xenon, radon. Now what I am supposed to write over here? 3s2, 3p3, because there is no d over here. We have to fill like this, n minus 1d, whatever the nth orbit, we have to write down n minus 1d, n minus 2f, n minus 2f. So over here I will write 3d10, 4s2, 4p3. This will help you in knowing the inert pair effect. If you don't know this configuration, you won't be able to understand inert electron pair effect. Now 4d10, 5s2, 5p3. Now this one, see to it, this is 6th orbit. I will write 4f14, 4f14 and 5d10, then 6s2, then 6p3. Now over here, you know very well. Now see, now focus over here. This F is diffused, D is also diffused. Their screening constant is very poor. This I will let you know. This will make use in your further questions. You will find use of it. If this is clear to all of you, let me move ahead. This table, how many of you, this is really very important table, how many of you want to learn this table? Very important table, very important. Just do let me know in the chat section how many of you want to make it clear in your brain, you want to have it. Just do let me know in the comment that chat section. Just do let me know. Just do let me know. Okay, everyone wants to have command on it. Just if you want to know it, hit the like buttons. Hit the like buttons. I want to see your likes to get increased, and if you're new, do subscribe the channel. Do it fast. Do it fast. Okay, see to it, everyone. Atomic number is very clear. Atomic mass, it is okay. Electronic configuration I have told you. Ionization energy. Focus on ionization energy. See, ionization energy. You know very well the minimum amount of energy required to remove one electron from the outermost orbit of an isolated gaseous atom in its ground state, that is known as ionization energy. Suppose if I take nitrogen, see to it, let me write down nitrogen over here, see to it carefully everyone. If I write down nitrogen, phosphorus, arsenic, antimony, bismuth, you have seen nitrogen was having electronic configuration helium 2s2 2p3, and if I talk about bismuth, helium, neon, argon, krypton, xenon, it was which period? 1, 2, 3, 4, 5, 6 period. That means I was having 4f14, then 3d10, 4f14, then 5d10, then 6s2 and 6p3. This much is clear to all of you. If I say these are diffused subshells, what does it mean? Diffused subshells, what does it mean? Can you understand? Their screening effect is very poor. Their shielding effect is very poor. Are you getting my point? Their shielding effect is very poor. Can you understand this word? What I mean? Their shielding effect is very poor. Can you understand this word? If you are not able to understand shielding effect, do let me know in the chat section. I will tell you shielding effect means what. See, let me tell you what is shielding effect. Suppose if I have got one tree, proper tree, this is proper tree with leaves, spherical leaves, and here is the sun, and here is Ela standing below this tree. This is Ela. This is Ela standing below this tree, and sunlight is not able to approach that much. It's not getting that much. It's summer days. You can say summer days, and the temperature is 48 degrees Celsius. First case, this is the tree name is S subshell. Now let me draw another tree. This is, leaves are like this, leaves are like this, leaves dumbbell shaped. Sun rays are coming, dumbbell shape, P subshell. Same Ela is standing over here, Ela is standing over here. Now, if I say I am with dry leaves like this, dry leaves like this, dry leaves, they will not occupy too much space. Ela once again is standing over here, this is Ela standing over here, dry leaves means D subshell, not occupying too much space, diffused one. Now, if I say frozen leaves, you can't even see the frozen leaves, F for frozen leaves, F for frozen leaves, F is too much diffused, So, everywhere Ela is standing, just do let me know which Ela is having proper sunlight, means I will not, I'm not going to use proper sunlight. I would like to say which Ela is finding herself uncomfortable, which Ela is electron, Ela means electron, see the analogy, try to understand the analogy. Ela is for electron and this is nuclear force, force of attraction, nuclear force. Just do let me know which Ela is experiencing maximum sunlight, which Ela is experiencing maximum sunlight, S1, S, and this, in these two cases, the dry and F, diffused, and frozen leaves, D and F, means these trees are duffers. You can see these two trees are duffers. Can I say these two trees, two types of trees are duffers? Can I use this word? Diffused. So, they are not able to stop the sunlight. They are not able to stop the sunlight up to that much of extent. That means their shielding, their screening is very poor. Screening is very poor. Can I say screening is very poor? So, see to it everyone. Screening effect is like this. Screening effect S maximum, then P, then D, then F. They can't stop nuclear force of attraction. Can't stop nuclear force of attraction. Is this much clear to all of you? And with the help of this, I will let you know. Inert electron pair effect. I will let you know metallic character. I will let you know oxidation state. I will let you know each and everything. Are you getting my point? Are you comfortable? Are you ready to understand each and everything? Just do let me know in the comment section. Are you energetic? If you are feeling, or if you are full with Josh, just do let me know in the chat section. Yes, Josh is very high. If your Josh is high, do let me know in the chat section. I want to see. Yes, now see to it how it is going to affect. See, if I talk about ionization energy, if I go down nitrogen, phosphorus, arsenic, antimony, bismuth, one is the nuclear force of attraction. If I go down If I go down, nuclear force of attraction is increasing. Nuclear force of attraction is increasing. And this nuclear force of attraction says that ionization energy should get increased. If this nuclear force of attraction is increasing, this suggests that ionization energy should get increased. But another factor, this is not only the one factor, this is a factor number one. This is your factor number one. According to this factor, ionization energy should get increased, but on moving down the group. But on moving down the group. But on moving down the group, you can see number of shells are increasing. So the size of atom is getting increased. Size of atom is increasing. Size of atom is increasing. That means if I talk about period, this is first, this is second, this is third, this is fourth, this is fifth, this is sixth. That means bismuth electron will be in the sixth orbit, you know, far away from the nucleus, very, very far away from the nucleus, and nucleus won't be able to attract the outermost electron with that extent. This is indicating that DNF, they have poor screening effect, so nucleus will apply more force of attraction on the outermost electron, but the size is indicating that electron has gone too far away that anyone can come, put a little amount of energy and it can eliminate out extra electron. Are you getting my point? This and this is saying ionization energy should get increased, but that factor is more dominating. This factor is more dominating. This is dominating factor that its electron has gone far away. So ionization energy should get decreased. So who is the winner? Factor number 1 is winner, or this factor number 2 will be winner? Just do let me know in the chat section, this factor number 1 is going to win or the factor number 2 is going to win. So definitely the answer is factor number 2 is going to win, and this factor is the winner. So the ionization energy, if I talk about first ionization energy of nitrogen, first ionization energy of nitrogen is absolutely, or you can say 1400 kilojoule per mole. 1400 kilojoule per mole. Once it has lost one electron, it will develop one positive charge. So this is the first ionization energy. If I talk about its second ionization energy, it will be approximately 2800 kilojoule per mole. Why the second ionization energy is more? What's the reason behind why the second ionization energy is more? This is more because it has lost one electron. Once one electron has been lost, its repulsion between electron will get decreased and the force of attraction will increase. Why this is more? Dear kids, why this is more? What I am talking about? Nitrogen's first ionization energy is approximately 1400 kilojoule per mole, and if I talk about second ionization energy, that means it's not nitrogen, it is N plus. This will be more because force of attraction by the nucleus is increased and force of repulsion got decreased. So ionization energy is somewhat 288 kilojoule per mole. If you have NCERT, you can see the data. No need to keep in your brain. No need to keep the data in your brain, but let me tell you, order. If I talk about nitrogen's third ionization energy, just do let me know in the chat section, will it increase or decrease? What do you think? Will it increase or decrease? Just do let me know in the chat section, will it increase or decrease? I want your answer. So answer is definitely it will increase, and it is somewhat 46, approximately 4600 kilojoule per mole. Why that much change is there? Because force of attraction has increased too much, and force of repulsion has decreased too much. Can you see? That means nitrogen has very high ionization energy. Now see to it what I am saying. Nitrogen has its ionization energy more than carbon as well as more than that of oxygen. Why? If I talk about nitrogen's ionization energy is more than that of carbon as well as nitrogen. Its ionization energy is more than fourth group as well as sixth group. Reason is its half filled stability. I think this point is very much clear to all of you. Now, if this much is clear to all of you, do let me know in the chat section, everyone. This point is clear to all of you. Ionization energy, you see 1402, 2856, 4577, what I have told you, and it will keep on decreasing. It has gone to be 703 kilojoule per mole. That means bismuth's ionization energy is less and this is very high. If this point is very much clear to all of you, just do let me know in the chat section. Now size has got increased or not? I think yes. Just do let me know in the chat section. Is it visible now? Okay, now see, everyone see to it. If I talk about electronegativity, once the ionization energy is more, electronegativity is also more. 2.12, 1.9, 1.9. Now covalent radii, ionic radii on moving down the group, they has to get increased. Now this is the most important point, melting point and boiling point. Melting point and boiling point, this is the most important point. Just to learn it and just to keep it in a brain, just remember number 3, 4. What I am talking about? Number for melting point, do remember number 3, and for boiling point 4. What does it mean? 3, 4. If I talk about melting point, boiling point, see, nitrogen, phosphorus, arsenic, antimony, bismuth. You can see very clearly 1, 2, 3 up to this third element, melting point increases. Arsenic got maximum melting point, and what I am saying, number for melting point the number was 3, and for boiling point, what I have told you, for boiling point number is 4. So up to which place, up to which element boiling point will increase? Nitrogen, phosphorus, arsenic, antimony, means up to antimony boiling point will get increased. So antimony got maximum boiling point, maximum BP. 3, 4, just number is 3, 4. Do remember the number 3, 4. This is for MP and this is for BP. See to it. See, melting point 63, 317, 1089. This is maximum. Arsenic's melting point is maximum. And if I talk about boiling point, see 70, 554, 88, 1860. Its BP is maximum. Its MP is maximum. Is it clear to all of you? If Is it clear? No need to learn the values. No need to learn any value. Just you should remember the trends. My dear kids, let me make it very clear. No need to learn the values. You should know just the trends. And density increases down the group. No problem is there. You should know only the trend. Till now, if everything is clear, just hit the like buttons, dear kids. Hit the like buttons. If till now everything is clear, hit the like buttons. Now I am going to tell you each and everything about nitrogen. Only trends. No need to learn the values. If till now, my dear kids, I want to she is writing what? Fantastic, awesome. I have never seen such a great teacher. Wow, great. Thank you. Now, if everything is clear, show your energy level. I want to see the energy level. Yeah, waiting for marathon sessions. I will let you know in the marathon each and everything. Just show your energy level. Hit the like buttons. What are you doing? Hey guys, what's going on? How's the Josh? If you're new, just subscribe the channel. Now see everyone. First of all, my kids, guys, just let me know, are you getting benefit? I'm taking plain slides. See how many slides I have. I have got number of slides. If I show you the slides, I have got number of slides. If you can see the slides, see number of slides I have got number of questions, but I am using plain slides because I think that in better way I can let you know. Each and everything. Okay. So, see to it. Properties of nitrogen, I will let you know. Okay, melting point, boiling point, I have told you physical properties. Now, oxidation state. This point is very, very important. This oxides of nitrogen, I will let you know. But first, let me know, are you getting benefit because of these plain slides? I am just writing so that it is going to form a photographic memory in your brain. That's why I am not using already written slides. I am using plain slides, blank slides. I want to increase my speed, but what's the benefit if I am going without making clear in your brain? That's not going to benefit. It's not of any benefit. Okay, right. See now, oxidation state is very, very important. These are the lines which have been taken from your NCERT. See, the common oxidation state of these elements are -3, +3 and +5. But what they are writing, the tendency to exit -3 oxidation state decreases down the group. What does it mean? -3 oxidation state decreases down the group. See, bismuth, if we talk about bismuth, +3 oxidation state, bismuth is going to show +3 oxidation state only, +3 only, and its +5 is very less. +5 is very less. That means bismuth forms +5 only with BiF5. This is the only structure of bismuth which shows +5 oxidation state. Otherwise, bismuth's +5 oxidation state is not stable. Better to say bismuth. Let me tell you why and how. Let me tell you the reason. See to it. Everyone see to it. Everyone focus over here. Nitrogen, phosphorus, arsenic, antimony, bismuth. Mc, to leave it of no use. Now, if I talk about its electronic configuration, do you remember? Helium, neon, argon, krypton, xenon. Do you remember? Do you remember the electronic configuration? Do you remember? It was 2s2, 2p3, 3s2, 3p3. But here 3d10 was there, then 4s2 4p3, then here was 4d10 5s2 5p3. Now here 4f14, then 5d10. Do you remember? Do you remember? Everyone, do you remember this configuration? Now see, its nucleus must be applying maximum force of attraction. Its nucleus must be applying maximum force of attraction. Force of attraction will be maximum. So this force is coming. Suppose this arrow is coming. This arrow is coming. Zoom. This arrow is coming like this. Zoom. They won't be able to stop this arrow. The force of attraction arrow, these are the diffuse subshells. Their screening, shielding effect is very, very poor. Do you remember what I have told you? Shielding effect was very, very poor. Shielding effect very, very poor. So they won't be able to stop this force of attraction, and the force of attraction will say, oh, S, I won't let you go. I won't let you go. You can't go. I have captured you. I have captured you. Just like dog is saying to rabbit, hey, I have captured you. See, this will not allow these s electrons to move. Somebody is going to snatch these electrons, but this nucleus is saying, I won't allow you to go. 3. P1 you go, because you are to moving like this away from the nucleus, but this is spherical. This is spherical. This is spherical, and its percentage of S character is more. Its percentage of S character is more. So this S electron won't be able to go. Only these 3 electrons will go. So the +3 oxidation state is more favorable. In this case, this will go. This will go 5. This will go. This will go, because there are not these duffers are not good over there. Diffuse subshells are not there in this case. So this will go. This will go. In this case, D is there. D was not that much diffused. D was not that much diffused, so no problem. But yes, stability of 5 oxidation state decreases down the group, because here if I talk about these 5 oxidation states are very, very stable. Very, very stable. Then what I will say, here the +5 oxidation state is not that stable, but if I talk about this case, there is fluorine, this is F subshell is also there. It is saying, oh my God, the nuclear force of attraction was 83, plus 83 was there. I can't hold that charge. So this arrow is going, and these 3 electrons will take part in the reaction, but these can't go. So this is +3. This point is clear to all of you? Is this point clear to all of you? Is this point clear to all of you? If yes, show the Josh, show your thumbs up, and likes button. So less likes. What are you doing? Okay, now see, if I say +3 oxidation state decreases, what will you say -3 oxidation state? If this point is clear to each and everyone, just do let me know. -3 oxidation state will increase down the group. That stability of -3 oxidation state, do let me know in the chat section. -3 stability of -3 oxidation state. What will you say? -3 oxidation state, stability of -3 oxidation state will increase or decrease. So the answer is that will decreases. Deena ji, fantastic. Decreases down the group. What's the reason? Decreases down the group. Could you please let me know what's the reason? Decreases down the group. Decreases down the group. What's the reason? Just do let me know what's the reason. Reason is the force of attraction is increasing, but number of shells are increasing. Number of shells are increasing. It cannot take electron of others. It cannot take electrons of others because it has gone far away. What has gone far away? The outermost electron has gone far away the reach of nucleus. Far away from the reach of nucleus. Now see to it everyone. If I talk about nitrogen, phosphorus, arsenic, antimony, bismuth, what was the code? Just do let me know what was the code in the chat section. What trick I have told you? What trick I have told you? What trick I have given you? Nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth. Which trick I have given? NEET paper answers. NEET paper answers will be provided by SBI with the radioactive mic. Newspaper, yes, NEET paper answers will be provided by SBI with the help of mic. Chalo. These two are non-metals. These two are non-metals. These two are metalloids. Metalloids. And this is being metal, poor metal, better to say poor metal, poor metal, poor metal. So this much is clear to all of you. Now let's move towards oxides of nitrogen and each and everything. Very good, fantastic, fantastic. NEET paper answers, NEET paper answers. And one comment, I can't see paper, NEET paper answers. Now see, inert pair effect, it's given over there, +3 oxidation state. The stability of +5 oxidation state decreases and that of +3 oxidation state increases, right. This so we know what we have done, okay. So stability of -3, see -3 oxidation state, I have told you it decreases. Don't get confused, what I wrote over here, -3 oxidation state decreases and what is written over there, don't get confused, don't do the cramming. +3 oxidation state increases. Why +3 oxidation state increases? Due to inert electron pair effect. It is not going to release these two electrons, So +3 oxidation state, stability increases, -3 oxidation state, stability decreases, +5 oxidation state, stability decreases. 3 points are there. Just do let me know, is it clear? Yes. So the answer is clear. +3 increases down the group as we go down the group, -3 decreases, +5 decreases. I think this point is very much clear to all of you. Now see, oh, this is the most important point, very, very important. Very, very important. Why this is very, very important? Very, very important. Very, very important. Let me tell you. HNO2. What do you call it? HNO2. You can write it like this or you can write it like this. HON double bond O. What is the oxidation state of nitrogen over here? Oxidation state of nitrogen 4, 2 to the 4 plus 1, 3. 3 is in between -3 and +5. What do you think? What is going to happen? It is in between -3 and +5. In acidic medium, what it is going to show? It is going to show disproportionation. Disproportionation means this will oxidize as well as this is going to reduce. So if I take 3 moles of HNO2, 3 moles of HNO2, I will get what? I will get HNO3 plus water plus NO. Just see to it. Look over here. +5. +5 means what? This is undergoing oxidation. It has undergone oxidation. And see over here, +2. +3 to +2, it has undergone reduction. The same nitrogen is undergoing oxidation as well as reduction. So, we will call it disproportionation reaction, and this reaction is going to give you the best possible thing and which is going to affect the answer. If you are not able to find it out, if you are not able to keep it in your brain, you will miss the question, miss the answer. You are not going to get the correct answer. But yes, if you are going to remember it, definitely you will get correct answer. See, if I say, how will you prepare? Oh, this is once again the most important memory chart, or better to say, this table is very important. This table is very important. Table is very important. Now, in which part you find difficulty? Just do let me know in the comment section, chat section, which part you find difficulty. I think you will feel difficulty in bond angle, this bond angle, and you will find difficulty in boiling point. These 2 points are really very important. The boiling point is really very important, and this bond angle is very important. How many of you want to get the logics about these 2 points? Just do let me know in the chat section. How many of you want to get logic behind it? Yes, do let me know in the boiling point. Okay, I want to see what you want from my side. Boiling point, see, boiling point. Just see, nitrogen, phosphorus, arsenic, antimony, bismuth. How many elements we have got? 5 elements we have got. We have got 5 elements, total 5 elements. Just bring this nitrogen, keep it over here in between phosphorus, arsenic and antimony, bismuth. So, what I am saying, PH3, ASH3, okay, then SBH3, then BiH3, and just put your nitrogen over here. Reason I will let you know, but order you got, first just let me know the order of boiling point you got. This is having maximum boiling point, and this has got least BP, least boiling point. Now see, why it is here in between? Can you think over it? It is over here due to intermolecular hydrogen bonding. The reason is intermolecular hydrogen bonding. Intermolecular hydrogen bonding. It is over here due to intermolecular hydrogen bonding. Now, the next point is very important. If you see about the bond angle, here the bond angle is 107 degree, but here bond angle is only, see to it, only 90, somewhat near about 90. Could you please let me know? What is the hybridization in this case? Ammonia, PH3 phosphine, ASH3, antimony, bismuth. In these 4 cases, in these 4 compounds, just do let me know what is the hybridization. What is the hybridization? Do let me know. Then I will tell you the most important thing. I am waiting for your answer. What is the hybridization over here? In these 4 compounds, what is the hybridization? What is the hybridization? Do let me know in the chat section. sp2, sp2. Yeah, that's fantastic. But I want your likes. I want to see your energy. I am that much energetic, but I can't see your energy. I want to see your energy first. Okay, Okay, some are writing sp2, some are writing sp2. This is wrong answer, wrong answer. Some are writing dsp2. This is also wrong answer. So the correct answer is no hybridization. In these 4 cases, there is no hybridization. No hybridization. Have you got shocked? Have you got shocked? No hybridization. Thank you, Itame, Biku, thank you. No hybridization. What happened? No hybridization. sp3 also not the correct answer. No hybridization. So no hybridization according to Drago's rule. How many of you want to know Drago's rule? According to Drago's rule. Reason is Drago's rule. Drago's rule. I will let you know this Drago's rule. That's why the bond angle is approximately somewhat 90 to 94 degree, and here it is 107 degree, although they all are having one lone pair, one lone pair, one lone pair, one lone pair, but these 4 compounds, they don't have any hybridization. How many of you want to know? Okay, see what is Drago's rule. See to it. Drago's rule. I am going to tell you about Drago's rule. Drago's rule any element of 5th period, 6th period, like that. No, not period, group. Any element of 5th, 6th group and 3rd period or below what I am writing, any element of 5th group, that is nitrogen, phosphorus, leave nitrogen, phosphorus, arsenic, antimony, bismuth, or 6th group, leave oxygen, sulfur, selenium, tellurium, polonium, like that. Okay, and 3rd period and or below. First point is this, it must follow this condition, and second point is if the surrounding atom, is hydrogen or like element means electronegativity should be less than 2.2 or less, 2.2 or less. These are the 2 things which are required, better to say, that surrounding atom's electronegativity must be like of hydrogen or less electronegative, and that element should be belonging to 3rd period or downward side. See, now see, this Drago rule says these type of compounds will not hybridized. Now with the help of this you can solve any question. If you know this thing, you can solve any question, any of the question you can solve. See to it. Let me tell you. Suppose if I say nitrogen, what is the atomic number? 7, 1s2, 2s2, 2p3. If I consider these outermost electrons, what I will write? 2s2, the ground state configuration is 2s2 and 2p3, 2s2 and 2p3. This is the ground state configuration, right? Ground state configuration. Now if I say excited state, so this is S, this is P, electrons will not get over there. But if I say excited and hybridized state, if I talk about excited and hybridized state, what will happen? They will combine together. Like this. This is S spherical and this is P doubled, but once they have hybridized, just like if you take a juice of 1 orange and 3 pineapple. If you are asking for a juice, a glass, just a glass of juice, 1 orange that is round, spherical, and 3 pineapples like that, slim and trim, you will get a glass of juice which is having pineapple as well as orange, but part of orange will be 1/4 and rest of 3 part will be of pineapple juice. Once the juice you are having, you can't separate into pineapple and oranges because they are mixed, that is hybridized. Yeah, Drago's rule is in your syllabus because in NCERT bond angle is given, each and everything you will get from the Drago's rule only. Now, how to fill the electrons? You are going to fill the electrons like this. Is it clear? sp3. So, the condition of nitrogen is like this, 1 lone pair, this is hybridized, and sp2, 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 they all are sp2. Agreed? They all are being sp2. Here is the lone pair, 1 electron, 1 electron, 1 electron, and it will combine. So, all they are sp2. First, let me tell you, this is sp2, this is sp2, this is sp2, this is sp2. So, they are with 5 electrons. They are with 5 electrons. How many more electrons they are in need of? 3 more electrons they are in need of. So, this is ammonia, and ammonia is said to be sp3 hybridized. So, we will sp2, no, wrong, they are not sp2, they are sp3. See, everyone is sp3, 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 sp3. So, don't do this mistake, sp2, sp2, this is also sp3, can you see? This is also sp3, this is also sp3, this is also sp3, this is also sp3, all they are sp3. So, the hybridization of ammonia is sp3. Never do this mistake, don't call it sp2, because in ammonia we can see very clearly there is 1 lone pair. So, steric number is going to be 1 lone pair and 3 sigma bond, 3 sigma bond. So, the sum is coming out 4. And the hybridization is going to be sp3. So, hybridization is sp3 and shape is pyramidal because of lone pair. Till now is it clear? Till now is it clear? Till now if it is clear to each and everyone, just do let me know how to find out hybridization. Let me tell you, over here you can find out nitrogen. Nitrogen is having 5 electrons in the outermost orbit. It has formed a bond with 3 hydrogens. So, you can see how many sigma bonds? 1 sigma bond, 2 sigma bond, 3 sigma bond, 1 lone pair, 1 lone pair. So, just find out steric number. Steric number is number of lone pairs plus number of localized sigma bonds. So, how much it is coming out? Number of lone pair 1, sigma bonds 3, 4. So, S1P3. I think this is clear to all of you. How to find out hybridization? Just find out steric number. Okay. Just I will take 15 minutes more. Let me tell you the oxides of nitrogen. Then I will end up this class. Just be with these concepts. Can you give me 15 minutes more? Just I am asking for 15 minutes more. Everyone, do let me know in the chat section. Can you please give me 15 minutes more? I am asking. Just give me 15 minutes. I will give you 15 marks for your NEET. I am asking for 15 minutes more and I will give you concept for 15 marks. See to it. Now, if I talk about phosphorus, if I talk about nitrogen, phosphorus, arsenic, antimony, bismuth, suppose if I talk about bismuth is also having electrons in the outermost orbit. See how to write it down: nitrogen, phosphorus, arsenic, antimony, bismuth. You can see 1, 2, 3, 4, 5, 6. So, it is like this. 6 S2 and 6p3, 6s2 like this, 6s2, 6p3, 6s2, 6p3. Now this is the ground state. This is your ground state. Now if you talk about hybridized state, no hybridization. They will not hybridize. They will not mix. No hybridization. Why no hybridization? Could you please let me know what's the reason for it? Because you know that nuclear force of attraction was very high over here because of the poor shielding effect of D and F subshell. Yes, do you remember? Do you remember? Poor shielding or screening effect of D and F subshell, the force of attraction was very high. So they are like this. They only going to form bond. It's S has said no. I'm feeling too much experience by force of attraction by nucleus. I can't go. I can't go. I can't go. I can't mix with you people. So these are three pure p orbitals. Pure p orbitals. Can you see? Can you understand? And this is pure s orbital. Pure s orbital. Can you see what I am talking about? Pure s orbital. Pure s orbital. This is pure s orbital and they are pure p orbital. Can you see? Means I am having this time the juice of orange, pure orange, a glass of juice of pure orange, and they are having a glass of juice of pure 3 pineapple. It's not mixed. I will cover up the rest of the groups in the marathon. Don't worry. Understanding is very much required. Just to complete without knowing is not good. I will give you questions also. I have MCQ questions. Now see, these are pure p orbitals. Now see, no hybridization is there. So how bismuth is going to form? How bismuth is going to form bond? See, in bismuth, this is pure S, pure S, pure S, pure S, and this is hydrogen, pure P, pure P, pure P, no hybridization, pure P. That means bonding without hybridization. Bonding without hybridization, bonding without hybridization, bonding without hybridization. Now see how it is going to affect. Now each and every thing you will be able to understand. Each and every trend will be clear in your brain. Are you ready? With the help of this Dragos rule, you are not required to cram any part. No need of cramming is required. You will be able to understand each and everything, my dear students. Now let me show you. See, let me show you number of questions. See to it. See everyone, the bond angle is decreasing. The bond angle is decreasing. Are you getting my point? Bond angle is decreasing, and this, see to it, this energy is over here exothermic, means when this bond is formed. See, this is negative. Can you see? For ammonia, this is negative. Can you see? This is exothermic. In case of ammonia formation, this is exothermic because hybridization has taken place, but in rest of the cases this is being positive, and this positive is indicating that bonding without hybridization. Bonding without hybridization. Have you ever gone through it? Have you ever thought like this? Why in case of ammonia this is negative, and why in case of rest of others it is positive? Why the value is positive? In all these cases it is being endothermic, and only in case of ammonia formation it is being exothermic, because only in case of ammonia hybridization took place. In these cases no hybridization. That means bonding without hybridization. Have you ever seen? Just do let me know in the chat section. Have you ever seen like this? Why this is happening? Now see the stability. How many of you are in search of what's the reason for stability of hydride, reducing character, and bismuth is the strongest reducing agent. These 3 points, how many of you are searching for the reason? Do let me know in the chat section. How many of you wanted to have reasons for this? How many of you wanted to have reasons for this? How many want to have logics? How many of you want to know the logics? Everyone used to cram these 3 parts. Everyone used to cram these 3 parts. I'm going to let you know the reasons. Pahan. Okay. Pani, water. Let me have some water. Just do let me know in the chat section how many of you wanted to know the reasons, the logics behind it. These 3 points. But first hit the like buttons. I need some. Ruhi. Okay. Okay. I wanted to see each and everyone's expression in the chat section. Okay. Now see. Before going to the board, this smart board, before moving towards that side, do let me know one thing, that relation of equality is good. Relation of equality is good. Within 10 minutes I am going to complete it. Relation of just 10 minutes, just 10 minutes, just 10 minutes. Let me tell you the reasons for this, and let me tell you the most important thing. The most super important thing is going to come. Don't leave the lecture. Stay with us. I am going to let you know the most super awesome thing. But first do let me know, relation of equality is good. Smaller is good. Larger is good. But smaller larger is not good. See. Then I will let you know, I will make you see relation. Just let me know which relation is good. Relation. Do let me know which relation do you think is good. Bonding. Which bonding is good? Relation means bonding. A option. Smaller cation, smaller anion. Smaller cation, smaller anion. Good or bad? Definitely good. Good. Good means lattice energy will be more than hydration energy. Lattice energy will be more than hydration energy. Thermal stability will be more. Now if I talk about B option, larger cation, larger anion, what do you say? What do you say? Larger cation, larger anion. This is also more stable. More stable. But if I talk about 2 other relations, see to it. If I talk about C, smaller cation, larger anion, yeah, you're getting larger anion, smaller cation. What do you call it? What do you call it? Good or bad? Very, very bad relation. Very, very bad bonding. So, big bond. I would like to say it is a big bond. Least thermally stable, will break down easily. Least thermally stable. If you are agreed, do let me know in the chat section. If you are agreed with my point. These 2 are good, but these 2 are bad. Agreed or not? Just do let me know in the chat section. Agreed or not? Agreed. If everyone, thank you, Dilip Kumarji, thank you. From the entire core of my heart, I am saying thanks. Really. If you can understand my hard work. If you are agreed, just show me. Do let me know whether you are agreed or not, and hit the like buttons. What are you doing, dear kids? Hey guys, what are you doing? I can't see that Josh. I can't see that Josh. Hit the like buttons. I want to see your likes. Likes should get increased. And I want to see your Josh in the chat section. I want likes. If you are awake, if you are getting something from here, just put, yes, you press the like button. Press the like button. And if you are new, do subscribe the channel. Yes, I can see students. Yashwin, yeah, very good. Now see. Just do let me know the size of, what do you think? Size is increasing or decreasing? Nitrogen, phosphorus. If nitrogen is like this, phosphorus will be like this. Arsenic must be like this. Antimony must be like this, and bismuth must be like this. So who is largest in size or who is smallest in size? This is being smallest and this is going to be the largest. Now could you please let me know? Hydrogen is small or big? Hey everyone, could you please let me know hydrogen is small or big? Hey everyone, just do let me know hydrogen is small or big. So the answer is hydrogen is very small, very small. So small is most stable with whom? Hey hydrogen, your bonding, your friendship is going to be the biggest good bond, smaller. That means ammonia's bonding is best. This is best friendship. This is going to be best bond. We are not going to break our friendship. He is saying like this. Hydrogen is talking like this. I am not going to break bond. And bismuth. Oh my dear bismuth, you are too large. I am very small. Very poor. Very bad bonding. Poor bonding. Can you see? BiH3 bonding is very poor and ammonia's bonding is very good. This is the cramming part or just the logic behind it? Is, yeah, RIP for hydrogen, very good. This is the logic or to cram? Just do let me know in the chat section. Is this the cramming part or this is a logic? Is this the logic? Is this the logic? Logic is here or not? Do let me know logic or cramming part. This is the logic or the cramming part. This is the logic here. Logic is over here. Now see everyone, the magic. Magic begins now. See the magic. Hydrogens will be like this. See, one more part I am going to tell you. Nitrogen is most electronegative. So hydrogens are like this. And these electrons are negatively charged, negative charge, more repulsion, so more bond angle. Without Drago's rule, I can let you know more repulsion, so more bond angle, But they can't be trigonal planar. Why trigonal planar? They can't be because here is lone pair, valence shell, electron pair repulsion theory. Valence shell electron pair repulsion theory says कि lone pair will occupy maximum space. They have to accommodate over here only. But if I talk about bismuth, hey bismuth, your electrons has taken by hydrogen. Hydrogen has taken away your electrons. Oh dear, your electrons are taken by hydrogens. These are being hydrogens. What happened here? What are you doing? Your electrons has been taken by hydrogen. What you were doing? So see, the condition is like over here. It's like this. So less repulsion because electrons have gone far away. Electrons are far away. So least repulsion, and least repulsion means least bond angle. Least repulsion means least bond angle. So without Drago's rule, I am trying to tell you the logic. Now see, which bond is weaker? Which bond is weaker? Which bond is weaker? So definitely this bond is weaker. This bond is weaker. This bond is weaker. Weaker bond. Weaker bond. All three bonds. One rende anche. One renda anche. All three. One renda anche. All three are weaker bonds. All three are weaker bonds. So they will take away its electron, its own electron as well as bismuth's electron. So thermal stability is maximum over here. Maximum thermal stability. Least thermal stability. One point is very much clear, I think. I made myself very clear. Least thermal stability. First point is very much clear to each and everyone, I think. I hope this point is very much clear. Now let's focus on second point. I know Tamil because I was there in Kerala, Thiruvananthapuram. I was there in Kerala in Thiruvananthapuram. One rende anche are ette umpat pad padvana padaranda irvad. Oh, vellamilla. So little bit I know Tamil, little bit, only little bit. So see to it. One thing is very clear. One point is very clear that on moving down the group, am I right? My accent was okay? Just do let me know. My accent is okay? One rende mule nale, anche are ere ette umpat pad. Malayalam, yeah. Actually, when I was there in Thiruvananthapuram, I was in class 3. And we were singing one song. The song is, please don't mind, I don't know, I don't remember. I was in class 3 at that time. I am a disco dancer. Kapil Dev Adichya sixer. Kirmani Pidichya catch out. At that time, I was in class 3, 4, 5. And at that time, we used to sing a song in our class that I am a disco dancer. Kapil Dev Adichya sixer. Kirmani Pidichya catch out. Am I right? Childhood memories. These are my childhood memories. If I am wrong somewhere, please don't mind. Huh? Thank you, my dear friends. Thank you. So, one point I made. Oh my God, I can see that much love in the comment section. The comment section has become colorful. Oh, great. Thank you. I'm perfect. Oh. Chalo, let's see. Now, let's see. One point is very clear. Now, switch over to second point. See to it. Now, if I write NH3, I will write like this. NH3. Just focus on number of electrons and where are they? Nitrogen's electron are nearest to it. Hydrogen can't take away nitrogen's electron because even hydrogen's electron are nearer to nitrogen. Hydrogen can't snatch electrons of nitrogen. Why? Because nitrogen's electronegativity is 3. Because nitrogen's electronegativity is 3. But if I talk about, dear kids, bismuth, bismuth's electron has gone far away. They are spending their time with hydrogen. Hydrogen is feeling, oh great, I have taken away your electrons. Now, which is better electron donor of bonded electron? Could you please let me know? Wow, yes, I will try my level best. P block is not completed. Oxygen family, halogen family, I will complete. Yeah, we will complete, okay, in marathon, right? Right now, just focus over here, and I can see your love. I can see your love in the comment section, but you are not hitting the like buttons. Please hit the like buttons and share to yourself, all the friends, and at least say to yourself that you are getting something. Then hit the like button. See, bonded electron who is going to donate easily, just do let me know. Bismuth electronegativity is just 1.9, least electronegative. So bonded electron who is going to donate first, just do let me know. Bonded electron, which element will lose first? Yeah, which element can lose easily? Which element can lose easily? Nitrogen or bismuth? Option A, nitrogen. Option B, bismuth. What I am talking about? Bonded electron. What? I am talking about bonded electron, not the lone pair. I am talking, just focus over here. I am just talking about bonded electrons. Who is going to lose first? Who is going to lose first? The bonded electrons. Bismuth. That means bismuth will easily lose electron. Bismuth is good reducing agent. Are you getting my point? The one who is losing electron easily means better electron donor. Better electron donor means good reducing agent. That means this is good reducing agent. One more point is very much clear to all of you. Good reducing agent. That means we got 2 points very clear in our brain. That ammonia, nitrogen, phosphorus, phosphine, arsenic, antimony, bismuth. On moving down the group, what is happening? Reducing nature is increasing. Clear? This point, is this point clear? On moving down the group, is this point clear to all of you? First point is clear to all of you. And on moving up, thermal stability is increasing. Is this point clear? On moving upward side in the group, thermal stability is increasing. Okay, these are the 2 points. Now, if the examiner is asking one thing, who is better hydride donor? Who is better hydride donor? Haloarines I will take. I will take haloarines. Just do let me know, out of these 5 entities, who is best hydride donor? Do let me know. Who is best hydride donor? Out of these 5 entities, who is best hydride donor? Third point. Bismuth hydride. Yes, very good. Wow, you have become pro. Very good. Best hydride donor. Very good. Fantastic. Really awesome. You got the logic. Third point is BiH3 is best hydride donor. Very good. Now, two more questions. Are you agreed? Are you ready? After that, I have to finish this session because Ambika ma'am's session is there. Otherwise, I wanted to give you, thank you Vaishali ji. Otherwise, I wanted to give you the most important thing, oxides of nitrogen. That was really important, but there is lack of time. So, 2 more points I am going to give you. They are very, very important. Then I will finish this session, but 495 likes are there. I want to see 500 likes. Then I am going towards the board side. Just I want 500 likes. These likes. Okay, see 1 point, 2 point, 3 point. Just give me your 4th point. If question is there, most basic is, this is the most important point, my dear friends. This is the most important point and most confusing too. So don't give the wrong answer. Try to give the best answer. A, ammonia. B, phosphine. C, ASH3. D, antimony S3, and E, BiH3. Just do let me know who is most basic. Ammonia. Okay. Areva, that's fantastic. That's really awesome. It's 501. Ammonia is the correct answer. See why. Ammonia is the correct answer. This is the correct answer. See why. These electrons and these electrons are very, very near. Can you see? And these electrons, most important thing, in ammonia, these electrons are sp3 hybridized. How much is the S character, percentage of S character? I am going to tell you the most important thing, super awesome thing. Just stay tuned. I am going to give you the best thing. You will never get anywhere. I am going to give you the best thing. This is sp3 hybridized. What is the percentage of S character? Lone pairs percentage of S character. Do let me know. What is the percentage of S character? Suppose we are having one pizza and this pizza has been divided in 4 parts. How much you will get? This pizza has been divided among 4 students. You are going to get 1/4. That is 25% only. So only 25% S character. Am I right? There is only 25% S character. But let me tell you, here in bismuth, no hybridization. When there is no hybridization, the lone pair was in pure S orbital. I have told you, no hybridization. So there was lone pair was having 100% S character. Am I right? Are you getting my point? Everyone just do let me know. Are you getting my point? Here the percentage of S character is 100%, and here the percentage of S character is just 25, whose lone pair can be easily snatched. whose lone pair can be easily snatched? Just let me know. Here the hold is 100%, nucleus hold is 100%, here the nucleus hold is just 25%. So who will donate its lone pair easily? If you liked it, show me your reaction. To every action there is equal and opposite reaction, Newton's third law of motion. So can easily donate its lone pair, can easily donate its lone pair. Now last point, I will take 1 minute, just 1 minute, I will take just 1 minute, last 1 minute. I hope this point is very much clear to all of you. Last 1 minute. Question is, which entity is most acidic? Yeah, which entity is most acidic? Okay, which entity is most acidic? Ammonia, phosphine, ASH3, antimony H3, BiH3. So I am not having that much of time so that I can ask you the question, because time is running very fast. Yes, oh my God, you know all the answers. Who is this? Semathi, Sarela, Vinod Kumar, Adina. Oh my God, everyone knows. Yeah, everyone knows the answer. Your answer is absolutely correct. Do you know the reason? Just do let me know. Do you know the reason the acidic strength is increasing like this? But you know the reason. Do you know the reason? Hey all, just do let me know. Do you know the reason? Okay, just I am asking one point. Negative charge is most stable on smaller atom, biggest atom. Negative charge is most stable on. Most electronegative atom or less? Negative charge is most stable on most electronegative atom or least electronegative atom? Just do let me know. Most electronegative atom, least electronegative atom. Just do let me know. Out of these 2 points, this is the question. Negative charge is most stable on. Do let me know. Let me check it out. How much good is your concept? Most electronegative. Okay, if you are saying that negative charge is most stable on most electronegative atom, then according to this, its electronegativity is how much? Nitrogen's electronegativity is 3, its conjugate base is going to be most stable and its conjugate base is going to be least stable. Then your answer will get wrong. If you are saying this is the answer, most electronegative atom, then your answer will get wrong. Nitrogen oxide I will take in marathon. Remember that. This will not work. First of all, we have to see the size. On second number, we have to see the electronegativity. Always remember that. Always remember, my dear kids, always remember one point, the most important point. Always remember. First point, the most important point, size matters a lot. Negative charge is most stable on. Negative charge is always most stable on biggest atom. Always most stable on biggest atom. Always see the size. Biggest atom. This is the point to be noted, my lord. Always stable on biggest atom. If the size of atom is same or approximately same, then negative charge is most stable on most electronegative atom. Always do remember, this is the point to be noted, my lord. This is very, very important. If size is same or approximately same. Second point, on the second preference, you are going to see if what I am saying, if if size of atom bearing the negative charge, atom having the negative charge is same or approximately same, then negative charge is most stable. Negative charge is most stable on most electronegative atom. Most electronegative atom. Clear? Now I have to leave, otherwise Ambika ma'am will start beating me. So guys, I have to leave, otherwise I'll be in problem. Bye to all of you. We'll meet you on Wednesday. Tomorrow is Wasim sir's marathon for physical chemistry and I have to leave. All the best. Bye to all of you. Bye. 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 Bye to all of you. All the best. All the best.